Okay, so for this problem, I'm asked to find sigma 1, sigma 2, and tau max in KSI. And this is given data. I'm given in the x-axis 400 micro inches per inch, which that already tells me that that is my strain in the x direction. And I don't have to solve for it in the equations. I'm giving negative 150 micro inches per inch and 250 micro inches per inch. So then here I use these the strain rosette equations, and so I just plug in the data. And so here the mistake that I made initially when solving the equations is that I referenced the angle from uh, in, from here to the x-axis and from here to the x-axis, which messed up my solutions in the equations. As you can see here, all I do is just plug in the data. And so it was the cosine of 75. And this is given. So I just plug in for the EX, for the strain in the X, sorry. And then I would end up simplifying and getting this equation 1. And then for the third strain in the C, 250 equals this. Cosine of 75, and then 75 would give me this. The 75 angle would end up giving me this constant times the strain in C, strain in the Y, and then plus 0.25 gamma xy. It gives me this equation, which is, if you notice, exactly the same. And when you solve for it in the calculator and the 2x3 system of equations, doing row reduce, gives me this solution, which doesn't make any sense because 0 variables in the strain in the x and strain in the y does not equal 1. So then I tried again, the same process, exactly the same, but instead of doing a 75 degree, I did a 75 degree in one, and then adding both of them here as 150, as it was done in one of the problems in class. And so here, like I said, it's just theta A, theta A, theta A. I just plug in 75, 75, and 75, and it gives me this for equation 1. And then for equation 2, I get plugging in 150, which is the 75 plus the 75 degree angle, 150, 150, 150. And it's simplifying the 400 as well, like I did in the first one. It gives me negative 50 equals 0.25 in the y. Strain in the y minus 0.43301 gamma xy. And so, like I said, solving the system of equations with 2x3 using our REF in the calculator gives me this fraction, which I just plug into the calculator. It gives me negative 190.89 micro inches per inch. For gamma xy gives me this times, which is just this microradians. And here, so then I just transfer the data to take the next step. And so the next step that I will take is the left one, which is just after I find the state of strain, I use a generalized Hooke's law to find the state of stress, and then I will use Moore's circle to find the principal stresses. So then here I just transfer this data, E in the X equals 400 micro inches per inch, or just times 10 to the negative 6 inches per inch. Sigma Y equals negative 190.89 times 10 to the negative 6 inches per inch. And then gamma xy equals 5.258 10 to the negative 6 radians. And then I just looked in the back of the book to find the modulus of elasticity, the modulus of rigidity, and Poisson's ratio. And so here the next step, it's easy just to plug in for these equations that we took in class. So sigma x equals E1 minus V squared EX plus VEY. And so this term I solve for in both, and it ends up giving 11,396 to make it a little bit easier. And then this one I just plug in for 100 times 10 to the negative 6 plus 0.35 times strain in the y, which is just negative 190 times 0.89 times 10 to the negative 6. And when I solve for, when I solve for in the calculator, I did it ahead and I got 3.79 KSI. So for the sigma y, I use the same equation, it'll just vary by this term, and it is equal to the same thing as here. So it's 396 times EY, strain in the y plus Poisson's ratio times this. And so that ends up giving, in the y is just negative 190.89 times 10 to the negative 6 plus 0.35 times 400 times 10 to the negative 6. And when I plug into the calculator and solve for these terms, it gives me negative 0.579 KSI. Okay, and the last one, gamma xy, as given in the notes. So tau xy is equal to modulus of rigidity times gamma xy. So gamma xy is just equal to 5.258 times 10 to the negative 6 radians, and then modulus of rigidity as given in the book, 3.7 times 10 to the, or 3700, I should say, same thing. So when I solve for this, it ends up giving in the calculator 0.0194 KSI. Okay, and the last step, I just use this, and yep, there you go. Let me see the example that was done. Oh yeah, that's right. I need to use the steps. Where are the steps? I remember now. The steps are, I think, at the beginning. Oh, come on. There you are. Sorry about that. So first step is begin with so I have this data now, and it is here. Yep. So sigma, oh geez. Begin with the known state of stresses. Sigma x is equal to 3.79 KSI. Sigma y is equal to negative 5.579 KSI. And tau xy is equal to 0.0194 KSI. Step 2, plot sigma x comma negative tau xy. So sigma x is just 3.7 KSI comma negative this value. There's 1 point, negative 0.0194. Okay, and then the next, and the second point is just this one. Yeah, I'm sorry, it's this one. Yep, okay. Negative, oh geez, it's actually behind. Negative 0.579, comma, positive tau xy. And that is 0.0194 for all intents and purposes. And step 3, draw the diameter, and let's say it's here. Then locate the center, and to locate the center, it's just the average of negative 0.579 plus 3.79 divided by 2, and it gives me 1.605. 1.605. Okay, that is a center. And so, and then I draw the circle. Okay, and then step 6, find the radius. So I get this portion and this portion as it was done in class. And this is 3.79 minus 1.605, 2.185, and then this section is just 0.0194. Okay, and to find the radius r, I use Pythagorean theorem, 2.185 squared plus 0.0194 squared so I square that plus 0.0194 squared, and then the square root 2.185. Okay. 2.185 is the radius, and okay, and identify sigma 1, sigma 2, and tau max. So because this is the radius, 2.185, this would be tau max. Tau max 2.185 ksi. Sigma 1 and sigma 2. So how do you find sigma 1 and sigma 2? Let me see real quick. Oh, that's right. So I get 8.83, that's the center, plus the radius. Okay, the center plus the radius, 1.605 plus 2.185, and then 1.605 minus 2.185, as it was done in class, in the lecture to find sigma 1 and sigma 2. So 1.605 plus 2.185, and I get 3.79 KSI, and 1.605 minus 2.185 and negative 0.58 KSI. And that is it. I found tau max, sigma 1 and sigma 2.